Welcome to the Visible Heart Lab at the University of Minnesota. I am Tina Niles.
And I'm Lars Madison, a PhD candidate here in the lab.
So here we're just going to show you a little bit about what we've been up to today. And this is actually a heart that's been reanimated outside of the body. We were using a clear perfusate, and it's being pumped utilizing pumps, but it's actually beating on its own in a fully physiologic mode.
As you might have guessed, we're very interested in heart cardiac physiology here. And so you can see we have lots of different tubes here that are connected to measure different things throughout the heart. So you can see right here we have this tube coming into the right ventricle. And that actually is connected to a pressure transducer down over here. And that is giving us this light blue trace here. And so every time the heart beats, we can see that change in pressure and how much pressure the right ventricle is generating. We also have this yellow trace here and the red trace here. The yellow trace corresponds to the left ventricular pressure, which is this transducer down here, and then the red trace is the arterial pressure. You'll notice down here on the left ventricle, we also have several wires coming off the heart. Those are actually connected to little piezoelectric crystals, and each one of those crystals will emit a little ultrasound pulse and then listen for another one, and then we can use these crystals, based on how long it takes for the signal to get from one to the other, we can determine the distance. And then based on the distance, we can actually determine the volume of the left ventricle, because we have a set of crystals on the front and the back, and then one at the top and the bottom of the heart. And then based on that, we can determine the volume change, and then we can look at the volume change over time of the heart as it's beating on the apparatus.
So we're not only interested in the physiology, but also the anatomy. And so just to give you a brief overview of the external cardiac anatomy, you have your right atrial appendage here, and then going into that's your right atrium through your tricuspid valve, down into your right ventricle, out through the right ventricular outflow tract, pulmonic valve, and then out, and that would be going to the lungs. And then you have return of this clear perfusate into the left side. You can also see your left atrial appendage right here. And that's going into your left atrium through the mitral valve into the left ventricle, out through the left ventricular outflow tract, and then out through the aorta. And this is the tubing that's here as well. So we also are taking a 3D 4D echocardiography here. So this is a probe. It's a transthoracic echocardiography probe that's connected to this machine here. And you can see the functional anatomy of the aortic valve and then the mitral valve here as well.
You'll also notice that we have these catheters that are placed on the epicardium of the heart here. And these catheters, there's one here on the external part of the heart, and then on the endocardium below, you can see on monitor 8, there's actually the catheter on the inside of the heart as well. And those catheters are capable of recording monophasic action potentials, which actually can monitor the electrical activity of the individual ion channels within the heart. And so you'll notice here on monitor 5, the sharp depolarization of the sodium ions, the maintenance of the depolarization or the plateau with the calcium ions, and then the repolarization of the potassium ions. And so we can use that to see how different drugs or how different disease states affect the function of the different ion channels within the heart.
So then obviously a great part about the preparation that we have here is that we can use these endoscopic cameras to visualize the tissue-device interface and the functionality of the heart anatomy.
So thanks so much for stopping by today. Hope to see you again soon.
Bye!